Okay, so let's see here. Starting in the first section, use a graph to estimate the absolute extrema and local extrema. So let's see, we've got an absolute maximum. Where's our absolute maximum? Yes, absolute maximum equals 4. Absolute minimum, again, we're estimating it, so we're going to say approximately 1/2. Excuse me. What? Yeah, if you look here, you've got a maximum of 4. It is still an absolute maximum. It just happens to occur at 2 places. Okay. The absolute minimum is the same thing. It occurs at 2 places, but it's still an absolute minimum. Okay. We've got a relative. What? Let's see. We have a relative minimum and a relative maximum. Where would our relative minimum be? Can you have a relative minimum that is also an absolute minimum?
Yeah, but what they call it relative. Well, I mean, it's the biggest and the smallest in that spot, but it's also the biggest and the smallest overall.
Yeah, I'm trying to get to my notes here. Let's go back and let's look at the definition of our relative minimum, relative maximum. Let's see here. Okay, if there is an open interval containing C, right, where f of C is a maximum, then it is called a relative maximum, right? So yeah, it's kind of unclear, isn't it?
It's like, I feel like when we do absolute, we never say that that's also the local. Like, when they ask us to write the local.
Yeah, it's kind of unclear because it's a graph and it's not defining a certain interval. So yeah, I'm gonna leave it like that because the relative is actually the absolute in both of these scenarios. Yeah, we're gonna leave it like that. Okay.
So you write the relative?
No, I'm sorry. Okay. If we were defining the interval to be, something like that, then that, even though that is the maximum, absolute maximum, we would call that a relative maximum. Okay. How about number 2?
Negative one, sorry.
A relative minimum. Yes. A relative min of 1. Okay. How about a maximum?
Absolute maximum of 4.
Yeah. There is no absolute minimum. Okay. Right. Okay. Do you have any questions on the other 2 graphs? Say again? Yeah, so this is because it just has to be continuous. It doesn't say anything about differentiable. So yeah,
So that'd be
that would be a relative minimum, yes. Because these points over here are actually lower, but they're not absolute because it's going to continue. Okay. Okay. Okay, let's move on. Determine the critical numbers. How do we find the critical numbers? Yeah, we got to take the derivative. Good. So let's see, f prime of x. And there's no interval here because critical numbers would also include endpoints, but we don't have any endpoints. They're not giving us any endpoints, right? So, yes. We're just identifying the points for the chart. Hey, you have to take that quiz because you just came in late. Okay, so we're just identifying the critical points. We're not actually trying to find the the extremas, right? So what's the derivative of a natural log? Right, so it's 1 over x squared minus 4 times 2x. So that's 2x over x squared minus 4. Okay, so critical points are where f prime of x equals 0 or is undefined, right? So where is this going to be undefined? X equals 2 or negative 2. Does it equal 0 anywhere? Does this equal 0 anywhere? Yeah, so that would be when x equals 0. Okay. Okay.
You know what really updates scale? So
Yeah.
it makes it so there's like dots everywhere.
My key on my homework key is just not really. I didn't do a good job with that. So let me just look up.
You can try to move it with 2 fingers. So it's like the exact weight.
Oh, they did an update.
You're right.
Oh, that's because of the
I need to go back and erase the dots.
Yeah, you can't write.
Okay, is everybody paying attention? Okay, I went back to the notes. Okay, a critical number of a function is an x value in the domain such that either f prime of c equals 0 or f prime of c does not exist. Okay, so now let's go back. I need to get rid of some of those tabs here. Come on. There we go. Let's go back, right? We've identified points where f prime of c is equal, or f prime of x is equal to 0, and where f prime of x does not exist, mainly at 2 and negative 2. However, if we go back to the original function, what's the domain of my f of x? What's the restriction with natural logs?
It can be negative.
Can't take the natural log of a negative number. So x squared minus 4, where is that less than 0? X squared is less than 4, so x less than plus or minus 2. So how does that work? So we know that if less than 2, thank you very much. Okay, so if x is 3, is that going to work?
Yeah.
That'll be okay. How about if x is 1? No, so x has to be X has to be greater than 2. All right. How about, so we're looking, here's 2. Anything, shh. Anything less than 2, 1, 0, is that going to work? If I had 1, I'm going to get the natural log of a negative number, right? How about -2? Does that work? Can I take the natural log of 0? No. So -2 does not work. How about +2? Does it work? No. I'm going to have the natural log of 0. Okay. How about -3? Does that work?
Yeah.
Okay, so what's not working?
2.
Anything between
2 and -2.
2 and -2. Those are the things that do not work.
Yep.
Okay. So that means, what's my domain? My domain has to be greater than 2 or less than -2. Now, if you go back to the definition of a critical point, okay, look back at the definition of our critical point. It says any x values in the domain. Well, we just found 2 x values, 2 and -2, that are not actually in the domain. So these are not critical points. So why does that matter? Like, what's that going to do? Is 0 in the point in the domain?
Yeah.
I don't think so.
Why does that? Okay, so looking at this, we have no critical points. It's not no solution. It's no critical points. Okay, no critical. What does this matter? What? Tell me what's happening here. Yes, Gabby.
Well, then there wouldn't be a maximum or minimum, right?
There's no maximum or minimum, right? No critical point. So I don't have any point to identify. Yes.
You said on a certain domain or whatever, but when they give us an interval, isn't that giving us the domain? And we're finding where.
Yes, but in this particular case, this function has a certain specific domain. The domain of this function is not all real numbers.
But I thought you just said the -2 to +2 is the domain.
No, -2 to +2, that's where it does not exist. This is my domain right here. Greater than 2 and less than -2.
Because the points aren't on the domain.
Right. So this means there's no critical points, which means there's no maximum or minimum. There's nothing to test. If you were to look at the graph of this, okay, let's look. Natural log of x squared minus 4. Okay, natural log of x squared minus 4. Let's look at this graph in a standard window. Okay, what's happening? What's happening here? This is actually going on. Did I graph it correctly? X squared minus 4. Greater than 2, less than -2. Right? So this is actually an asymptote. Okay? This is where you have to understand your functions. Okay? Are you guys paying attention? Because you seem to be very distracting back there. Okay? This function is actually continuing down. This is a vertical asymptote. -2 is a vertical asymptote. It doesn't stop here, right? So if I evaluated f of, let me do this one, f of 2.0000001, right? Calculate value. Okay, let's do 2.1. Okay, we're getting a value. If I do a calculate value of, oops, no, stop that. Calculate value of 2.0001. Okay, see where my cursor is? Although the graph, it looks like that value, that does not exist. It looks like it's undefined there, but it's not. This is a vertical asymptote. Now, if I did calculate value at 1.9999, right, now I get blank here where the y is. We have to understand what we're seeing on our calculator, okay? This is a vertical asymptote. Although the curve appears to stop here, it doesn't. Yes, I don't know. I think it's, I don't know.
It's not just that one, it happens on
Yeah. The calculator plots a graph by connecting the points, but we clearly saw that one of the points fell here and it should have connected. So I don't know why it's doing that. Okay. Sometimes if we change it to the dot mode instead of connected mode, let me see, where do I do that on here? Detect asymptotes on. Let's see what it does if I do that. Didn't make a difference. Yeah. I don't know why it does that, but we have to understand what we look at on our graph. Okay? Understand the function. This is going to continue on. This is continuing down. This is continuing up. There are no extremas. And that's why we didn't get any critical points. So before we start looking for critical points, we have to determine what our domain is, right? So if you look at this one, what is our domain here? Right? It's a square root. We can only take square root of positive numbers. Okay? So where is that x squared minus 9 going to be greater than or equal to 0? Right? X squared is greater than or equal to 9. So x is greater than or equal to plus or minus 3. How does that work? Let's think that through. If it's greater than 3, right? So these get confusing. You really have to kind of think it through. If it's greater than 3, can I take the square root of that? Yes. So greater than 3 is going to work. Okay. How about less than negative 3? Is that going to work? Yes, it is. Right? So now we're looking at, this includes 3. Right? Let me rewrite that. Okay. So that's our domain. The x has to be either greater than or equal to 3 or less than or equal to negative 3. So we have to figure out our domain before we start looking at those critical points. Okay. So let's take the derivative now. Now we're ready to find our critical points. I'm going to rewrite this x squared minus 9 to the 1/2. Okay. So let's see, I've got 1/2 x squared minus 9 to the negative 1/2 times 2x. So h prime of x equals x over the square root of x squared minus 9. There's my h prime of x. So, just hang on a minute. We looked at h of x and figured out our domain. We know that our domain says the x's are either greater than or equal to 3 or less than or equal to negative 3. Now we're ready to find our critical points. We take the derivative, and from the derivative, my critical points are where h prime of x either equals 0 or is undefined. Okay? So where does h prime of x equal 0? At x equals 0, right? The numerator is 0. Where is it undefined? When the bottom is 0, which would be positive 3 or negative 3. Do all of those fall in my domain? Okay, does -3 fall in my domain?
Yes.
Does 3 fall in my domain?
Yes.
Does 0 fall in my domain?
No.
No, it does not. We do not consider 0 as part of my critical points. Okay, so this function does have a potential for a maximum or a minimum. Let's look at this curve. Okay, we're looking at the square root of x squared minus 9. Oh, gee whiz. Let's try that again. The square root of x squared minus 9. Okay. Okay. So, is that one continuing to go down? Is this an asymptote? No, because at -3, I get the square root of 0. Can I go beyond the -3? No. -2.999999, right? -2.99999 is going to give me the square root of a negative number. So when I look at this graph, it is actually stopping where it looks like it's stopping. Because if I put in a +3, I get the square root of 0, which is 0. If I put in 2.999, I get the square root of a negative number, which is not going to work. Okay, so that graph does make sense. So looking at that graph, I can clearly see that I have an absolute minimum in that graph. So my critical points make sense. I do have critical points. Okay, yes.
Could you leave it? So you know how you have like the first H prime, then you have like the final. Could you just leave it?
You can leave it like that. It's just harder to see the critical points when you leave it like that.
Because you could just set like x equals 0 and then set that x squared in the negative.
Yeah, it's just harder. I think it's more clear to see the denominator here, but yeah, you can leave it like that. Yep.
Like other problems where we find in the derivative instead of equal to 0 to find the critical points, but
We sure did. It's exactly what we just did.
You just found the domain first to see if the critical points were within the domain or not.
Yep. Okay. Number 7. What's my domain? Anything. My domain's all real numbers. Absolutely. So this is an easier one. So y prime equals 6x squared plus 2x minus 20. Okay, so I'm going to set that equal to 0. I'll take a 2 out first. 3x squared plus x minus 10. Let's see, 3, 1, 5, and 2. That'll work. Okay, so this is going to be 2 times 3x minus 5 times x plus 2 equals 0. So x equals positive 5/3, negative 2. Those are my critical points. Those are the points where we look to see if we have a relative minimum or maximum or an absolute. Those are the points that we're looking for that sign change. Okay. Okay, number 8. What's my domain? So the t squared, that's not going to be a problem. How about the cube root here? Can I take the cube root of a negative number? Yes. So this looks like my domain is all real numbers. Okay. But now taking the derivative is kind of a pain in the neck. T squared, we're going to do 2t minus 5 to the 1/3. All right. So this is a product rule. All right. The first times the derivative of the second. So that's going to be 1/3. It's 2t minus 5 to the negative 2/3 times 2. First times the derivative of the second plus the second, 2t minus 5 to the 1/3 times the derivative of the first, which is 2t. Ew, 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 ew. Ew, 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 ew. Okay, so let me see, I have a 2 and a 1/3, so I've got 2 on the top, 2t squared on top. All right, here's 2t squared up top. Down the bottom, I have 3, and then 2t minus 5 to the 2/3. Okay, so I'm going to rewrite that as the cube root. You don't have to, right? The cube root of 2t minus 5 squared. Okay, and that's going to be fine because no matter what I put in for t, I'm going to square it. I can take the cube root of anything. Okay, plus everything's on top here, 2t square root of 2t minus 5. Okay.
Miss Marie, how about the square root of 1 cube root?
Say that again?
How's the plus 2t the square root, not cube root?
No, that's a mistake. That should be a cube root. Thank you. Okay. We need to set it equal to 0. Well, that's really nasty. I'm going to put that in my calculator. You can factor a 2t out. You could factor a 2t out. It's the radical that's kind of nasty. Okay.
Your calculator will do it for you. Like 5 to 0.
Okay, so this is what I'm going to do, right? So,
Oh, that just seems like the trace thing.
okay, let me just, if you've all stay quiet a minute, I'll show you what I'm going to do. Okay, first I'm going to put the original function in here just to verify that my derivative is correct, okay? I'm going to go to math, and we're going to choose option number 4 for cube root, and that's going to be 2x minus 5. Okay, that's the original function. Okay, looking at that, there you go. We clearly have a minimum and a maximum, right? Okay, now, I'm actually not going to graph the original function. Now what I'm going to do is put in the function that I got as the derivative, which was 2t squared over 3 cube root of that. That's just so nasty. I'm going to do that next. Divided by 3, and then that's a cube root of 2t minus 5 squared. Is that what I got? Yes, okay. And then we're doing, was it minus? Plus, okay. Plus 2t times the cube root of 2t minus 5. Okay, so that's what I got as my derivative. I graph that, and it's this weird looking thingy, right? So because it's such a weird one, I'm going to just verify that my derivative is the same. It's correct, rather. So I'm going to go math, and I'll do n deriv. With respect to x, I'm taking the derivative of y1, so that's alpha trace, right, y1, for all values of x. If I took the derivative correctly, these two lines should be the same. And I made a mistake, right? So here's what I think I did before I abandon it. I think I need to put that 2x squared in parentheses. All right, insert parenthesis.
It might be dividing it by 3 and then multiplying it by the bottom too.
The 3 is on the bottom.
Yeah, but I'm saying like might divide it by 3 and then multiply that answer by the cube root of 2x minus 5. Yeah.
Okay, and then I'm going to put, this is okay because it's all in the numerator. Okay, let's check it again. I think it's the way I have it in there, to be honest with you.
It's just
Oops. There we go. Put that parenthesis back there. Come on. There we go. Just the parentheses. Okay. Okay. So be very careful with my parentheses. Gabby, yes?
I just have a question. So if, like, normally when I put something in, and then if I want to go back and, like, add, like, say if I want to add the parentheses, it, like, replaces the number.
So if you press second and above the delete key is the insert,
Oh, okay.
then you can insert it.
Okay.
Okay. Okay, so I had to make sure my parentheses were correct. Now I can see it is the same. Okay. All right. All that just to figure out the critical points here. So I'm looking to see where f prime of s, come on, s prime of t is equal to 0 or undefined. It's going to be undefined where the denominator is 0, right? No, yes, it will be. Okay. So how do we have to do that? First, let's find where f prime is equal to 0. Okay, so we can see it's equal to 0 at a couple spots. So let's turn one of these off. Right, and I'm going to do a calculate 0. Right, I'm finding where it equals 0. And it equals 0 at 0, so that's one of my points. There you go. X equals 0. Where else does it equal 0? So we're going to do it again. Calculate 0. I'm going to check this other one over here. Use my instead. 2. Okay, and then at 2.14 it looks like. All right.
You hit enter to get that line, like the dotted line going down. And like hit enter.
Yeah, I'll show you again. Okay. So what I did, okay, so we do second, calculate 0. It's asking for a left bound, so I need to make sure I'm to the left of that point, of this point right here, okay? Left bound, and it puts the dotted line there. And then it's asking me for a right bound, so I need to move to the right of that 0 and press enter. And it puts another dotted line. And then it's asking for a guess, so I just press enter. Okay? Okay. So those are the 2 zeros. But if you look, we also have to figure out where it's undefined. Now, where is it going to be undefined? This is a rough one. It's going to be undefined when this part right down here, is everybody looking? Some of you have checked out. You can't. You can't quit like that and give up. Stop checking out. If you don't understand, you need to be asking questions. Don't just sit there like, oh, I don't get it. Okay, don't do that. You guys are smarter than that. You don't get it, you ask questions. Because now I'm going to have to go back and redo it all because several of you have quit even trying to comprehend it like 10 minutes ago. This is going to be undefined where that denominator is 0. So what can I do to figure that out?
7 equal to 0.
Yeah, and we again use your calculator to do that.
For those, because like we see that 0, they're gonna cancel out. Can't you just do like the begin, like the parentheses, like 2t minus 5 equals 0?
I'm just going to put the whole denominator in there. I'm just going to make sure where's my denominator? 3 times the cube root of 2t minus 5 squared. I'm going to put that in my calculator. Okay? 3 times the cube root of 2t minus 5 squared. That's what's in the denominator. I'm just going to look at that on the calculator and find out where that equals 0. Because I know it's never going to be negative, and even if it was negative, that's okay. You can take the cube root of a negative number. Okay? So we're going to just graph that little piece right there. It never equals 0. Is that true? Is that true?
Well, I put
Is that true?
no.
Does that never equal 0?
I don't think so, because if you plug in 5 over 2, then it will equal 0, because then you're going to get a 0 squared times the outside.
You're going to get the cube root. You can get the cube root of 0 if we just have 5 over 2 here.
And then that
Because I'm going to have 0 squared, and then the cube root of 0 is 0. 0 times 3 is 0. So look, I just looked at my graph. This is another case where be careful. You got to know your function. You can't just plug it in there. Okay? So we're looking at an additional value of 5 over 2, right? This value right here, this 5 over 2, where did that come from? That's where it's undefined, right? These two values here, that came from where the derivative was equal to 0. Okay? And we had to use our calculator to help us with those two because that was a rough one. Yes.
Oh, so the 0 and the 2.14, those are zeros.
Those are zeros of the derivative.
And then the 5 over 2 is just undefined.
Yes.
Okay.
Yes. So this was a really hard one because first off, the derivative was challenging. And then finding the 0 of the derivatives was really pretty nasty. Okay. Another way of doing that would have been to set, okay, here's my derivative rate. Why is it doing that? Here's my derivative right here, right? When that equals 0. So I'd end up having 2t squared over 3 times the cube root of 2t minus 5 squared. We could set that equal to negative 2t cube root of 2t minus 5. You see where they are equal. But even then, you're going to need your calculator to help you out with that. Okay. Okay. I don't think we need to beat these to death. I think we've got the idea. Yes.
Sorry to go back a little bit, but when you were graphing the denominator, like
Mm-hmm.
didn't show that it hit the x-axis. If you look before the zeros, would it still give you the?
Good question. Right? So how would I do that? So we know that it actually hits 0 at 5/2, but it doesn't look like it on the graph. So if we did a calculate 0, and it's asking for the left of where we think the 0 is, so I'll press enter there. The right of where we think the 0 is, so I'll press enter there. And then we're just going to move closer to the guess, and it does give it to us. Isn't that crazy? It's telling me I have a 0, and you can't even see where the line goes there.
Is it because it's so narrow but slow?
I think it's just the algorithm it uses, the way it connects the points. Possibly if we change the scalar, let's do 0.1. Nope. Yeah, if we zoom, I bet we can see it if we zoom in.
Yeah. Because the way it looks is
Oops.
just like it has a really small.
There you go.
Yeah, it's really small slope.
Okay. so you can see it. Okay. Okay. So let's just reiterate, right? Because this is a common type of question, maybe not quite as algebraically challenging, but a common type of question on an AP exam would be to identify the critical points. And 9 out of 10 times, students will forget to consider the domain of the function. And you think you've got it correct. It's kind of like you mentally check this off. It's like, oh, this is easy. I can do critical points where the derivative is equal to 0 or the derivative doesn't exist. But you have to consider the domain, right? These problems up here, we found 3 critical points. None of them fell in the domain. So it turned out we didn't have any critical points. Okay? So if you look at this one here, what's my domain? Yes.
X has to be greater than 3 and X has to be less than negative.
I think my domain is that X, it's everything except for -3 and +3.
Oh.
Everything except, so my domain does not include +3 or -3. Okay? So when I take the derivative of this one, okay, I'm just going to save us some time. I get -2 times x squared minus 3x plus 9 over x squared minus 9 squared, okay? That's what I get when I get my derivative. Now, what are we going to do to figure out the critical points? Okay, so right away I know that two places where it's undefined, right? It's undefined at x equals positive or -3, right? Because I'm going to get a 0 in the denominator, so I know it's undefined there. But that doesn't matter because that's not part of my domain, right? So we can cross that out. So then we have to look at -2 x squared minus 3x plus 9 equal to 0. Okay, and this is kind of a pain in the neck because at x squared minus 3x plus 9 does not factor, so we'd have to look at the quadratic formula. Use your tool. Use your calculator. What's the easiest way to do this? Go to your apps, go down to number 9, right? Quadratic formula. We're going to choose polynomial root finder. You don't know about this?
Oh.
Okay, let me show you again. Okay. On your calculator, press the apps button. You can solve any polynomial equation on this. Okay. Choose number 9, polynomial simulator. Okay. And you're going to do polynomial root finder. Make sure it says order 2. That order is the leading exponent. Okay. We're in real numbers. We're going to choose next. And on your calculator, that means you press the button, the graph button, which is below the next. Okay. And we're going to put in our values. I don't remember what they are now. Let's say x squared minus 3x plus 9. So that's going to be 1. Enter. Minus 3x plus 9. Okay. So we do that, and then we click solve. No real roots.
Whoa.
Miss.
Yes, Gabby.
My number 9 is CS.
So you've got to find the one that says polynomial simulator.
I don't think I have that.
Okay, I'll give it to you. Yes. The graph button is underneath where it says next. That's what you press.
Oh.
Should it be in radians or degrees?
Always in degrees unless you're graphing trig functions. Yes.
So when we do critical points, it can't be imaginary numbers.
No, we're talking a real number
Okay,
system.
'cause I did it algebraically and I got it imaginary numbers, so that's why I just labeled it
Right.
critical.
Does anybody else not have it? Okay, the older calculators don't have it.
Come on, guys.
It's not second.
No, it's just
She's got a hacky calculator.
probably.
I'm gonna see if I can copy it over for you.
She's gonna hack it.
It may work, it may not. Sometimes you can't go from higher levels.
She's going to the Pentagon. She's getting the.
Yeah,
she's
I
getting
am.
the code for
I'm
it.
going to go to the Pentagon. Okay.
What did you have?
So we're going to go link.
She's up here.
Link.
She's doing
Ben.
We're
So
gonna
you
go,
diagnosed me
whoops.
fill out my survey, please. Your survey?
With ADHD.
Sure. I mean, my mom's a therapist, so I'm not like
Apps.
written. Okay, just say you. Okay.
For what?
Your second, my research is on ADHD.
Well, only if you're
I'm undiagnosed. I'll go get
Her mom said
diagnosed.
she has it. Her mom
Cambridge
said
should be.
well, yeah, well, that's not the H part, just the AD part.
I'm close enough.
Isn't ADD not a thing they use anymore?
It's all on the same spectrum of ADHD, so I guess it
ADD
is.
is not a
like
diagnosis.
What does ADHD
No,
stand
they
for?
were diagnosed.
Attention deficit hyperactivity disorder.
I just knew the attention deficit disorder.
Right.
They
The
even
H is the
send- they
hyper,
even
but
send it to you. It's the one that's
You need to
third
get a
grade.
different calculator.
So there's I haven't had
You
one
can do
single
it.
ADHD.
because like all of my friends got diagnosed
All
with
three of my
ADD
siblings and now
because all the girls,
My brother's
the girls were just like,
Girls
yeah.
are
It's actually
like
good.
actually
Actually,
Well, yeah. And then they're like, oh.
Okay, I broke your calculator. Okay.
You broke your calculator.
A lot of times it won't go from the higher calculators down. But I'm going to try again.
Calculator was.
You want to bring yours up, Jordan?
That's so cool.
Are you gonna break mine too?
You can
Yeah.
play video games or you can play like games up.
No game bang mom?
Carson. You too.
Yeah. Gabby, it won't work because yours is too old.
Alright.
I'm sorry.
How do you copy stuff over?
There's a link command. So you go to link on both of the calculators.
That's cool.
I'm
I'm a Flappy Bird my calculator, but I'm too scared.
I didn't hear from you.
I feel like if I put Flappy Bird my calculator, I'm never be allowed to use my calculator again.
Yeah, I'm sorry guys, your calculators are too old.
This is from 2011.
Yeah, it's 11 years old. That's really old in technology words.
When you're thinking
Yeah,
about
there's an iPhone 4 now.
Does anybody have a newer one that doesn't have that software? Okay.
I'm 13, so.
Okay.
Actually, it's also on camera.
So yeah, this is a really useful tool, guys. This polynomial simulator. I will show you. I might have a program that'll do that for you, actually. And yeah, I might have one. Yes,
What is the complex word?
complex root.
Yeah.
That's when it's an imaginary number, square root of a negative number. So also, this is really nice for the simultaneous equation when you're solving a system of equations. This is really, really helpful, right? You put your equations in. Okay, I got two equations, two unknowns, and then you can solve the system of equations. It's very helpful tool, especially on your AP exam, because you don't want to spend a lot of time doing the algebra. So on your AP exam, if you happen to have a system of equation that's there, let's say you had x squared plus 3x plus 5 equals 12, and then you had 4x squared minus 5x plus 2 equals 7, right? You don't want to spend time on your AP exam solving this, right? You can simply say, okay, X is equal to, I don't know, 3 or -2, right? You don't have to show the algebra doing that. You can use your calculator to do that. You can graph it and calculate the intersection, but that takes a little more time than using the app if you have the app, okay? Okay, we don't have a whole lot of time, do we?
6 minutes.
I gave you just numbers 1 to 10,
Yeah.
1 to 16. Okay, that's all right. So number 11, let's look at that one together, okay? My domain is all real numbers, right? Consider your domain first. I need to find my critical points, 3x squared minus 12x, right? Set this equal to 0. Okay, so we get x equals 0 or 4. Are they in my domain? Okay, is it in the interval that they've given me? Zero's not, right. So I'm not worried about the 0. So I'm looking at the points 4, where x equals 4, x equals 1, and x equals 6, right? Everybody got that? Okay, so we're going to say when x equals 1, 4, or 6, then y equals, let's see, 1 minus 6 plus 8, so that's 9 minus 6, so we get 3. And save myself some time. When I plug 4 in there, I get -24. When I plug 6 in there, I get 8 as an answer. So this is asking for the absolute minimum and maximums, okay? So it has an absolute minimum equal to -24, and it has an absolute maximum equal to 8, okay? Everybody okay with that?
Yes.
Okay. We're going to go ahead and stop there. No, because I've got students that didn't take it yet.
Oh.
Okay.
Come on, man. Come to school. No more ski trips.
Okay.
End of it. It says yes,
Okay.
no.
Let me see if I can find the program that I wrote for that.
You wrote it?